a coil of 0.01 Henry inductance and 1 ohm resistance and 1 ohm resistance and 1 ohm resistance is connected to is connected is connected to 200 volts 50 hertz AC supply AC supply AC supply. Find the impedance of the circuit. Find the impedance of the circuit find the impedance of the circuit and time lag and time lag and time lag and time lag between maximum alternating maximum alternating voltage and current. And current. Please note it. So let's solve the problem. The answer goes like this. Inductance 0.01 Henry, resistance 1 ohm, volts, frequency 50 hertz, impedance Z is equal to square root of XL minus XC whole square plus R square. How to find XL? Is omega L, that is 2 pi FL. XC is 1 by omega c, 1 by 2 pi fc. So can you plug in the values, everyone? So it is 2 pi. F is 50 hertz. Into 0.01. So said, where is the capacitor? Capacitor is not connected at all. Okay. So the capacitance part is 0. You don't have capacitor. So XC part is not given. Okay. Capacitor is not connected. Not connected. Since it is not connected, you can take XC as 0. No capacitor is here. So the formula reduces to simply square root of XL square plus R square. So plug in the values and then you can calculate the answer. The Z value happens to be about 3.3 ohms is what you get. That value is 3.3 ohms. Now, how to calculate? This is the first part. This is the easiest part. To calculate time lag. Time lag is based on the phase difference. It is given by delta t, that is pi by omega. This is called time lag. This is a formula for time lag. So how do we get this? So we get tan phi formula as XL minus XC divided by R. This we know very well. But the capacitor is not connected. It's simply XL divided by R. XL is omega into L whole divided by R. So plug in the value. So omega is 2 pi FC, 2 pi F, sorry, 2 pi F L whole divided by R. So plug in the things and then you can find the value of phi is tan inverse of 2 pi FL whole divided by R. So plug in the things. So you get tan inverse of 2 into 3.14 into F is 50. So L is 0.01. R is how much is R? 1. So when you plug in that, you get tan inverse of 314. So the phi value, you get the tan inverse of 314. That for that, when you use the calculators, you get about 72 degrees, approximately 72 degrees. This is what you get. 72 degrees, but you have got to convert into radians. So 72 into pi by 180. This is how you convert into radians. So that is in radians. And now what we have to do? The time lag phi by omega. So that is delta t. That is pi. Phi is 72 pi by 180. Omega is 2 pi into F. F is the 50. The frequency is 50 hertz. So this happens to be 36. So you will get 36 by 180 into 50. Further, it will cancel out. So definitely 9, you get 18 2s 36 and 18 10s you get, and again 2 5s you get. So you have 1 by 250. Okay, so 1 by 250 seconds. This is what you get. You can even change into decimals further if you wish. So what you can do is I multiply with 4 250, and then I multiply and divide with 4. Can you do that? So 250 into 4, our denominator is 1000, right? So on the top I have 4 by 1000. So it happens to be 0 0.004, right? Seconds. Or you can say that is 4 into 10 to the power of minus 3 seconds, or 4 milliseconds. So this is how you can give the answers. Is this part clear? Can I clear this? I'll clear this. Now the second question. A capacitor of 100 microfarad and a coil of resistance 50 ohms, and inductance 0.5 Henry are connected in series, with a 110 volt 50 hertz source with a 110 volt 50 hertz source. Calculate the RMS value of the current in the circuit. Calculate the value of the RMS value. Calculate the RMS value of current in the circuit. Calculate the RMS value of current in the circuit. Please note it. Can I clear? Noted?
Yes, sir.
Okay, good. Now, what is the formula of impedance? Z is equal to square root of XL minus XC whole square plus R square. This is the formula of impedance. And now, so square root of, how do you find XL? XL is omega L, that is 2 pi FL, and XC is 1 by omega C, that is 1 by 2 pi FC. So this is how we calculate. Substitute the values you get about the first one XC is 31.85 ohms. You get this one is 31.85 ohms, and the XL part is about you get 157 ohms. 157 ohms. Okay, we know the resistance. So plug in the resistance is about 50 ohms. So that's 50 square. XL minus XC 157 minus 157 minus 31.85 whole square. So this factor works out to be 134.77 ohms. 134.77 ohms. Okay, and then the IV is equal to, that is the, what is that? IV refers to this RMS. Okay, is ERMS divided by the impedance. ERMS is the RM, whatever the value they are giving, that 110 volts, that is called RMS value. Okay, that is the measurement by the thing, measurement by any system. So 110 volts you have to measure by using some instrument, right? Whole divided by Z is you got 134.77 ohms. So this works out to be about 0.816 amps. 0.816 amps. So that's the RMS value of the current.
Noted, sir.
Okay, now let's move on. The next one is called resonance condition. Resonance condition. What is this resonance condition? We'll see now. The resonance condition is like, see, in a series LCR circuit, when the phase angle, phi between current and voltage, between current and voltage, between current and voltage is zero, is zero, the circuit is said to be, the circuit is said to be, is said to be resonant circuit. Resonant circuit. The circuit is said to be resonant circuit. So the condition for resonance is, at resonance XL is equal to XC. Very important. At resonance XL is equal to XC. here the frequency is called resonance frequency. The frequency is called resonance frequency. Resonance frequency. Means what is that resonance frequency? The frequency at which XL becomes XC. That is called resonance frequency. So I'll write this point also. The frequency at which XL is equal to XC is called resonance frequency. The frequency at which XL is equal to XC is called a resonance frequency.
Noted, sir.
Okay, very good. Now, how do I apply these conditions now? So let's see this one. So XL is equal to XC. I think I have already done, but anyway, I will do this again. So we'll write omega R, which is called resonance frequency. Omega R into L, that is equal to XC is 1 by omega C. XL is called inductive reactance, XC is called capacitive reactance, which I already told you. And now omega R, will take it on one side. So I get omega R whole square, that is 1 by LC. And now take out the root. So you got omega R, that is 1 by square root of LC. Removing squares, that means if I remove square and take root on either side, you get this one. And omega R is 1 by 2 pi AF R will write, that is called resonance frequency. And this is resonance angular frequency, and this is normal resonance frequency, that is 1 by square root of LC. So FR, it's a very famous formula, 1 by 2 pi square root of LC, and the unit will be hertz. Hope you got it. So this is how we derive the resonance condition. At one more point, at resonance condition, let's calculate Z. Z is equal to square root of XL minus XC whole square plus R square. But XL is equal to XC, so this point goes to 0. So you get simply R, and that is impedance is minimum at resonance. Okay, we get the condition impedance is minimum when XL is equal to XC at resonance. Minimum impedance. And the second condition, I is equal to E by Z, right? Current is voltage by impedance. So that is like resistance. Impedance is also like a resistance. Okay, so I is equal to E by Z. Okay, so the current is maximum at resonance. At resonance you have maximum current. At resonance you have maximum current. This is the concept which you have to keep in mind. Let's solve one more question. Can I clear?
Noted, sir. Yes, sir.
Very good, very good. Now let's move on. Now we have a problem once again. One more problem. Calculate the value of calculate the value of calculate the value of capacity in picofarads. Pf means picofarad, which makes 101.4 microhenry inductance to oscillate with the frequency with a frequency of 1 megahertz, to oscillate with a frequency of 1 megahertz. So what are the things they have given? Please see that the resonance frequency they have given, that is 1 megahertz. Mega means 10 power 6. Mega means 10 power 6. So it's 1 into 10 power 6 hertz. So this is what they have given. What are the things you do? You know, the resonance frequency is given by 1 by 2 pi square root of LC. And now what you have to find is the C. So you can square it and then see. So FR square is 1 by 4 pi square. You have LC, right? So C we have to find. C is 1 by 4 pi square F square L. So plug in the things, that's all you have to do. 1 by 4 into 3.14 whole square, okay, into F square. So into F square is how much they have given? So okay, F square is 1, so that's 10 power 6 whole square into L is microhenry they have given, not 1.4 into 10 to the power of minus 6 Henry. Okay, these are the values you need to plug in. So you get the capacitance of about 249.6 is what you get into 10 to the power of minus 12 farads. This is what you get, the answer. and 10 power minus 12 is pico. 10 power minus 12 is pico. So it is 249.6 picofarad. This is how you get. That's the required capacitance.
Noted, sir.
Okay, good. Now let's move on to the another question. So the next one, a 2 microfarad capacitor, a 2 microfarad capacitor, 100 ohm resistor, and a 8 Henry and a 8 Henry inductor are connected in series with an AC source, with an AC source, with an AC source. What should be the frequency of the source? What should be the frequency of the source? What should be the frequency of the source for which the current drawn in the circuit, current drawn in the circuit, current drawn in the circuit is maximum. See this condition, when they say that current drawn in the circuit is maximum, it means that XL is equal to XC. So that is resonance condition they are talking about. If the peak value of, if the peak value of the EMF source is 200 volts. Peak value means E naught value they have given. Find the maximum current. Find the maximum current. Maximum current. Find the maximum current. Inductive reactance. Inductive reactance. Inductive reactance means XL. Capacitive reactance. Capacitive reactance. XC. Inductive reactance called capacitive reactance. Total impedance. Total impedance. Peak value of current. Current. All the parameters. What not. You can find all the parameters. Peak value of the current. This is what the first part of the question. Please note.
Noted.
Okay, good. The next part of the question is, what is the phase relation between what is the phase relation between voltage across inductor and resistor, also give phase relation between also give phase relation between also give phase relation between voltages across inductor and capacitor, voltages across inductor and capacitor. Noted.
Yes, sir.
Yeah, good. So we are getting a timeout, Amma. So can you log in once again? We'll close this now and please log in once again. We'll have the solution.